now for us. Welcome to Learning Unit 5. We're nearly there. We're nearly at the last learning unit. You guys have done all your ICE tasks. I think I've marked everyone's ICE tasks. Well done for getting them all in. So we've got one assignment left in our exam. So we're nearly there, and hopefully you guys are keeping up to date and managing with the content. Please just let me know if you've got any problems. Everyone in this module is quite quiet, so it would be nice to hear if we're all good and okay and keeping up with where we are. So we're going to start on Learning Unit 5, and I'm recording the session. I'll upload the recording afterwards for those who haven't joined us. This learning unit is on what is called the states of consciousness. Right now there's a lawnmower impinging on my consciousness, so hopefully it doesn't become too distracting. Right, so this learning unit 5, it's on the nature of consciousness, the first theme, and that covers what consciousness is and what it includes. We're going to look at the different states of consciousness. The second theme looks at biological rhythms and sleep, which is a state of consciousness, and we're going to be able to provide an overview of the roles of biological and circadian rhythms, and you'll understand what that is a little bit later. And we're also going to look at the sleep and waking cycle, which is important in our states of consciousness. It is an important state of consciousness, which we'll cover. So those are the different themes that we cover in this particular module on the states of consciousness. So the first thing we're going to do is just going back to the introduction in our textbook, and how did people start researching consciousness and what is consciousness. So what we'll learn about later is rapid eye movement, REM. Okay, so the discovery of rapid eye movements in sleep, that's a state of sleep, it blossomed into a number of other fascinating insights about what goes on in the brain during sleep. So when we're asleep, we're not unconscious, we're in a state of conscious awareness, but it's different from states we are in during the day. And it was seeing the concept of rapid eye movement helped people start to look at insights into about what happens in the brain while we sleep. And remember that psychology is a science, so it has to be studied empirically, scientifically. So it does lead to problems in terms of measuring and looking at consciousness, because consciousness is something that we're not always aware of. And when we study something, we need to do it scientifically and have replicable ways of studying something. So therefore it has raised a challenge as to how people study consciousness, because it's basically the ultimate subjective experience is your conscious awareness, and you can't see it in somebody else. Only you can understand what is happening in your consciousness, and your consciousness varies through different states over the course of a day or over the course of an hour. So it varies, and it's very subjective. But as we said, psychology is a scientific discipline that is continually evolving. And so researchers have been finding inventive ways to really look at what is inside somebody's consciousness. So a little extract there for you from a scientific journal, which maybe helps understand that concept a little bit more, that it's progressive and always looking for new ways to research things, is the science of consciousness has enjoyed a renaissance in the last couple of decades. And the study of our own minds, consciousness or subjectivity, has finally become a respectable pursuit. Remember, the first theorist who looked at consciousness was Freud. In the sort of early 20th century. So more and more people are looking at ways to discover and understand consciousness, although it's still tricky to determine what kinds of data and what kinds of experiments we should consider legitimate, and that's also ethical in the study of consciousness. So the science is evolving, and all the time we're learning more, and we're finding more and more ways to study people's consciousness. And that's just showing you how we're evolving as a discipline over and speeding up with the evolution of the discipline over the last few decades. So let's discuss what consciousness is, the nature of consciousness. So if I say to you, what is consciousness? Consciousness is the awareness, which is a very critical word. It means about being aware of something, and it's of internal and external stimuli. So a stimuli is something that causes a sensation or a response, and it's our awareness of those stimuli that makes up consciousness. So when we think about what an internal stimulus is, so what are we aware of in terms of our own internal stimuli? So we can think of that as things like hunger. We're aware of being hungry. We're aware of being thirsty. We're aware of pain. We're aware of our thoughts. We're aware of our emotions. Those are all internal stimuli or sensations that are happening, not outside of us in our external environment, but internally. And we're also aware of external stimuli. So if we think back to the chapter we've just done on sensation and perception, external stimuli are things like what we hear or what we smell or what we see. And so consciousness is an awareness of internal and external stimuli. Is that clear for you guys? Because it's really important you understand what that definition is. But as we work through the material, this definition will be expanded upon and you'll get more understanding of it. But it's really important to know that it's awareness. We're aware of something, and both internal to us and external to us. So remember that we are constantly receiving information from our senses and we're evaluating it. Therefore, what's in our consciousness, what we're aware of at any given time, is continually changing. So remember how we pay attention to some stimuli and not to others, or we pay more attention to certain stimuli. That's what's in our consciousness. That's what we're aware of. So we're always having sensory input, internal and external stimuli. And so it's the content of what we're aware of is always changing. And not only does the content change, but our levels of awareness to something change. So we're not at the same level of awareness all day. At some point of the day, we're asleep. At some point of the day, we are more aware. So maybe in the morning, we are more aware of things, and in the afternoon when we're tired. So our levels of awareness are changing. So what's in our consciousness changes, and our levels of awareness change. So it's a very fluid process. But we are always conscious unless we are pretty much dead. That is where we are completely unconscious, and we'll expand on that. So a nice little example to understand that a bit more, and I've put the reference at the bottom, is when you think about your daily life, okay, it's easy to get lulled into the belief that there is one setting for your conscious thought. That is, you likely believe that you hold the same opinions, values, and memories across the day and throughout the week, but you are actually like a dimmer switch on a light that can be turned from full darkness increasingly up to full brightness. This switch is your consciousness. At your brightest setting, you are fully alert and aware. At dimmer settings, you are daydreaming, and sleep or being knocked unconscious represent dimmer settings still. So if we think about our consciousness like a dimmer switch on a light, at some time during the day, we are brighter, we turn the lights up bright, we're more aware of things than at a different point in the day when the dimmer switch is dulled, okay, and we're not as aware. So that's sort of expanding on the definition for you. So if we go back to some of the history we learned right at the beginning of our first module, and we remember William James, and what he came up with was a stream of consciousness, that we are always conscious. Always there's new feelings, thoughts, and sensations being carried into our minds, and the stream continues to flow without fail. So that was an early theorist who came to that realization that consciousness is a permanent stream of things. And we also think back to Freud, and we discussed Freud in a little detail, and he was the first one to look at the fact that although we have the stream of consciousness, there are different levels to our awareness. okay, a bit like the dimmer switch that I spoke about. Think back to that. And it's not an all or none phenomenon. So you're not conscious or unconscious. It's not one or the other. It's different levels of awareness. And part of the nature of consciousness is the fact that it continually shifts and changes. And that's really part of the essential nature of what consciousness is. So Freud, he had, if you remember, he's got the conscious mind, which is the things we are really focusing on. But there is a level of a pre-conscious mind where there's things that we're not currently aware of, but we could focus on depending on our level of awareness if we increased it somehow. And then we've got the completely unconscious mind of things that we are unaware. So that's adding a little bit of history to consciousness, and it helps expand that definition a little bit for us, that it's a continual stream. And Freud said to us, however, there is a continual stream, but there are different levels of awareness. So although those theorists happened in the early 20th century, late 19th century, what they put into this concept of consciousness is important to understand, because that's where the foundation of understanding consciousness came from. Okay, are you with me on that? So what is consciousness? So we've said that it's an awareness of external events, and we've said it's an awareness as well of internal sensations. But it also is part of the fact that we are aware of ourselves experiencing certain events, and it's also about our thinking about how we experience things. So those four things actually make up what consciousness consists of. Okay, an awareness of external events, awareness of internal sensations or events, an awareness of ourself experiencing things, an awareness that we have thoughts about these experiences. So like we said, consciousness has different states or levels of awareness, and they range. When you think about your own daily routine, your consciousness, how conscious you are, ranges from being really alert and wakeful. But consciousness also goes to the other extreme of being in a deep sleep. And even though we're in a deep sleep, we are still conscious. Okay. At other times, our consciousness is wandering. We often get caught daydreaming, and our consciousness is just focused on one thing and thinking about it and neglecting everything else. We're not terribly alert because we're daydreaming. And for about a third of the day, we are sleeping, and that's when our awareness is dimmed down to that dullest dimmer switch setting of not being as aware. Okay, and we'll look at sleep a little bit later on. So there's different states of consciousness depending on what time of the day it is, what's happening, whether our mind is wandering or daydreaming. All of that impacts on our states of consciousness and our level of awareness. So it ranges really from conscious, being fully alert and completely conscious, and the far end of the spectrum is complete unconsciousness. And when you are aware of nothing, and nothing is sort of impinging on your senses, then really you are dead. And that's the only time we would be completely unconscious, with no wakefulness and no awareness. So research has shown us that we can maintain some level of awareness even while under anesthetic and whilst asleep. So even when sleeping, there are things that can penetrate our consciousness. They can wake us up. In some stages of sleep, they wake us up easier than other stages of sleep, but there are still things penetrating our consciousness. And external stimuli, like I said, can still penetrate consciousness even in those particular states. So the example in the textbook is, if a mother wakes up to a baby crying, it's an example of selective sensitivity to certain sounds. So as well is there are sounds that we are tuned in more consciously to other sounds. You might wake up to your baby crying, but you might not wake up to a door banging. Okay, because as a mother, we're tuned into our baby's crying, but not necessarily to a door banging. So again, things like selective sensitivity impact on what penetrates our conscious awareness, especially during sleep. So consciousness itself, okay, it's not a structure in your brain. but it's rather to do with your neural networks and pathways in your brain. And so we remember that the EEG is what we use to measure brainwave activity, and measuring brainwave activity is one of the ways people can research consciousness. So in our brain, and when they measure the electrical activity in our brain, they pick up different patterns of brain waves that are associated with different states of consciousness. So if we look at the different brain waves, they call the first wave a gamma wave. Okay, you can see that it's a very busy wave, which really is the height of conscious awareness. It's where we're problem solving, where we're concentrating, our brains are working, we're very alert, we're aware, we're paying attention to a specific problem or stimulus. A beta brain wave is slightly less busy than the gamma brainwave, and that's where our mind is active and it's occupied, but it's not quite that intense problem-solving focus that we have. Our brainwave changes again to an alpha brainwave when we are reflective and restful. So maybe we are lying on the couch watching something on TV that's sort of drifting in the background, we're thinking, we're peaceful, we're restful. That's our alpha wave. When we first start to go to sleep, when we get that drowsy feeling of going to sleep, our brain waves slow down even further. And once we reach into one of the stages of sleep, once we've passed drowsiness and we start to fall asleep properly, then our brainwave becomes very gentle, okay, and it's our sleep or dreaming brainwave. And that's how they measure the activity in the brain from the neural networks that are associated with states of consciousness, going from being incredibly aware and laser focused with our brains working on a problem to being asleep, where our brains and our neural networks show us the delta pathway. So that's what consciousness is. It's arising from those electrical neural pathways in the brain that are measured in order to look at conscious activity. And a lot of consciousness studies come from studying sleep, which we will come to. So when we think about what happens in our consciousness, let's talk about what they call biological rhythms, and we're going to talk about circadian rhythms, and we're going to talk about sleep. So biological rhythm are basically fluctuations in your physiological functioning that happen over the course of a day or sometimes longer. So if we think about a menstrual cycle, that's a biological rhythm. It fluctuates at different types of the month. Different levels of hormones are working at different times of the month. Our blood pressure functions, or it raises at certain times of the day. Our body temperature changes. So those are called biological rhythms, and they're very periodic. They fluctuate depending on the time of the day, the time of the week, or the time of the month. Okay. What a circadian rhythm is it takes the 24-hour cycle in our bodies, okay, that we have in humans as well as in animals. They also have circadian rhythms. So a good way to explain it is in the little the diagram that I put on the left there. So think about a 24-hour period. Let's start at the bottom from midnight when we are in deeper sleep, sort of between midnight and 2 o'clock. As we start to gradually move through that sleep cycle, when we start to wake up in the early morning, that's when our body temperature is at the lowest. About 6:45 in the morning, our blood pressure it's starting to rise. The hormones melatonin that helps us sleep, that secretion stops. Sometimes we go to the loo at about 8:30. Some people have very specific bowel movements in their circadian rhythms. And we move through the day. So maybe in the mid-morning is when you have your highest alertness at 12 noon. Maybe in the afternoon you have your best coordination at about 2:30. At 3:30 is your fastest reaction time. At 5 o'clock, greatest cardiovascular efficiency and muscle strength. Your blood pressure starts to go up at about 6 o'clock. Your body temperature starts to increase. You're at about starting to get towards bedtime, sleep time. The melatonin, the hormone melatonin starts to secrete. and you start to go to sleep and your bowel movements are suppressed. So everybody has that 24-hour biological cycle that they work on, and that's what is known as a circadian rhythm. And it's obviously not the same for everybody, and certain things impact on our circadian rhythms. But what studies have found is even when external time cues like sunlight and things like that are removed, that circadian rhythm generally persists. So it's a pretty fixed feature in our day-to-day activities, is that 24-hour cycle of how our body functions in a physiological way. So certain things happen, there's biological rhythms that take place in that cycle. And within that rhythm, like we said with the diagram, there are variations in things like alertness, our body temperature, and our hormonal secretion, going right down to the fact that our body temperature actually drops when people fall asleep. So that's what a circadian rhythm is, and it's basically managing those biological rhythms in a 24-hour cycle. And I think we all experience them. You might have your own variations, but on a whole, your physiological functioning happens in that cycle. So the circadian rhythm is an example of a biorhythm, and it does respond to a combination of internal and external factors. So our internal things that we call biological clocks are controlled by what is called the suprachiasmatic nucleus in the middle of our brain, okay? And that is what really where the serotonin is produced and the melatonin is produced. It impacts on that production, and it sort of regulates the amount of light that comes in that helps regulate our biological rhythms. So our biological rhythms, although they continue where there's sort of limited external stimuli, they're very much controlled by light and the amount of light, which is why at night we tend to go to sleep, whereas we're awake during the day. And it's that incoming light and its impact on the suprachiasmatic nucleus that then influences melatonin or serotonin production in terms of our hormone systems. So in modern living, and as we live today, there are things that can impact on our circadian rhythms. A lot of artificial lighting affects the level of melatonin that's produced, causing us to, which the melatonin causes us to feel sleepy. But if we've got artificial lighting, okay, it can impact on the melatonin production. Some people work round the clock, and so, or they're night shift workers. So sometimes there's a bit of maladaptation to the light and its regulation of that suprachiasmatic nucleus and the production of melatonin. So their sleep times may change or vary because they are actually working at night and they're sleeping during the day. So that can impact on our own circadian rhythms. Things like jet lag, when you travel and you cross time zones, that can impact on our circadian rhythm. It takes a little while to get back into balance again, to get that rhythm back into place. And a modern feature that we have is daylight saving, where people turn clocks backwards and forwards so that working days become longer, and different time cycles take place. So those are just in terms of modern living, okay, there are some influences on our circadian rhythms. And again, there is some individuality in this. Generally, your circadian rhythms start to take place when we're in early childhood or infancy. As a child, waking and sleeping is sort of regulated by the mother, by feeding, but it's sort of whatever happens in that phase of life continues across the lifespan. Some people are morning people sometime, and some people are nighttime people. So again, there's a little influence there between individuals. Most people fall to being better functioning in the middle of the day. Often there's a genetic variation. And often in adolescence, when there's a spurt of brain growth, people's circadian rhythms can change. Adolescents might go to bed later and then wake up later, but gradually that will change itself and it will become more regulated in terms of a normal clock. But often adolescents have that brain spurt, and their sleeping patterns change. So when we get out of sync, so you know that if we get out of sync, if we go to bed, we've got a function on and we go to bed later than normal, and we've been busy and something's on and we've gone and we've watched presentations and we've had a glass of wine and we've chatted to friends and we go to bed, we maybe don't sleep as well because our circadian rhythm the next day, we wake up at the same time, but our sleep pattern our sleep amount of sleep has been reduced. But generally, if you get out of sync with it, it can actually impact on the quality of your sleep. We've discussed jet lag and about flying across different time zones. And the impact of jet lag, I mean, we've seen it when sports teams travel. If they travel, they don't play the match straight away because their bodies have to get back into that ability to function in that effective 24-hour cycle. So circadian rhythms are important, and obviously they have an impact on our state of awareness at any given time of day. We are more aware at some point in the day than we are in other points of the day, and at some point of the day we're asleep, and then our consciousness is dimmed. So that is why circadian rhythms are important in understanding consciousness. Okay, are you guys clear on circadian rhythms and what they are and why they are important? Okay, so now let's consider sleep. So we've just said that a third of our day, in essence, a third of our day should be spent sleeping, okay, 8 hours a day. And sleep is considered an altered state of consciousness. So when we're asleep, we're not unconscious at all. We are in just an altered state of consciousness. We are aware, just a different level of awareness. And we don't remember everything that happens to us, but we are at some point aware of our environment. Okay, and we know that sleep causes a change in our brain because we've just seen that in the EEG readings. And we'll look at the EEG readings for sleep and the different brain waves that happen over the course of a sleep cycle. So why do we need to sleep? If we spend a third of our lives sleeping, why do we actually need to sleep? Why do we need to move into that sort of dimmed conscious awareness? Because basically during that time, if we think like animals and animals hibernate, it's during that time that our body basically starts to save energy, it restores us, and it repairs our body. So sleep is important for that. Okay, it's important to save energy, restore, and repair. Also during sleep, what happens is a lot of our memories are consolidated, and sometimes we even remember things in our sleep. We remember events. We wake up and suddenly think, oh, we wake up because we've remembered something we need to do. So our brain actually works to consolidate memories during that time. Sleep also clears our minds of useless information. Okay, it's a bit like a clearing room. When we sleep, we're not focusing on all of those useless pieces of information. They get cleared out of our minds because they move out of our short-term memory and they move into our long-term memory, or they get lost altogether. And often, or during sleep, growth occurs and growth hormones are released. So, you know, with children, where children get growing pains, and if you've got children, sometimes they wake up in the middle of the night crying because their legs are sore. It's often because at that point of development, growth hormones are being released. That's also why sleep is important, especially with children, because that's when growth takes place. And during our sleep, we also dream. So although we spend a third of our lives asleep, or a third of our day, or our 24-hour circadian rhythm asleep, sleep is beneficial. And I think we know that, and we can see that in the reasons why sleep is important to us. But once we go to sleep, what's actually going on inside of our brain? So we saw our changes in brain waves. So let's have a look and see what's going on inside of our brain. So we do experience, when we're asleep, physical and mental activity. When we sleep, we actually go through a cycle of stages, and we'll expand on that. Okay, so sleep is made up of a sleep cycle, where we move through different stages of sleep, and those different stages also are varying levels of conscious awareness. So we've moved into sleep, but within our sleep, there are different stages of conscious awareness. And the EEG readings can tell us what stage of sleep a person is in based upon their brain activity. And a sleep cycle generally is about 90 minutes long, and we typically go through 4 of those sleep cycles in one night. Okay. When we're awake and we're just drowsing off, we see alpha brain waves. which are the waves we saw a little earlier, and we'll see them again on the next slide. And once we begin to fall asleep, we enter the sleep cycle, which begins with stage 1. So sleep is cyclical, moving through different stages. We move through a number of stages in about each stage. Each cycle takes about 90 minutes during the course of the night. So when we come to sleep, okay, the EEG recordings tell us what's going on in our brain. Muscle tone can also tell us what's happening. There's autonomic activity and mental activity that can take place. So the very first stage of sleep, and we have two different sort of sections to sleep. One is the non-REM stage. So remember, REM is rapid eye movement. If you look at somebody when they're deep asleep, you can see their eyeballs or their eyelids are like jerking and flickering, and it's almost like their eyeballs are moving around. So remember, that's rapid eye movement. Okay, non-rapid eye movement is where there is sort of the eyes aren't moving, it's more a relaxed and restful state. So the very first, or the first 4 stages of sleep, and that sleep cycle we're in, the first 4 stages fall under non-rapid eye movement. And we measure it through brainwave activity. So the first stage is where we first go to sleep, and we have those alpha waves, which are sort of the restful waves, okay, giving way to lower frequency theta waves because we're becoming more relaxed and we're getting ready to go to sleep. So it's a bit like being drowsy, okay? If somebody enters into stage 1 and they're dozing off on the couch, and you give them a nudge and you say, "Are you sleeping?" And they sort of wake up and go, "No, I wasn't asleep." Okay, so it's almost like people wake up with a jerk and think they haven't actually been asleep. Okay, it's that first restful phase, and then gradually they move into the theta waves where there's a little more restful activity, and generally that stage lasts about 10 to 15 minutes. And for each person it's a little bit different, but that's a general sort of length of time that sort of drowsiness, first dozing off, happens. The second stage of sleep is where we spend a bigger portion of our cycle. Okay, so when we start to fall into a slightly deeper sleep, our heart rate decreases. You know, you see someone's breathing start to slow down, their muscle tension releases. The brain is idle at that point. It's not dreaming about anything. It's just generally relaxed. Our heart rate is lower and our muscle tension is much lower. We see in the sleep pattern, if you look at stage 2 in the sleep pattern, you see little things that they call K-complex, they sleep spindles. So that's something in the brain waves that people who are measuring brain waves can see when someone's entered that stage. These little sleep spindles occur. If we're in this stage of sleep, we generally tend to sleep to familiar sounds. Okay, so if there's something, if you're in your bedroom and you've got a fan on or an air conditioner buzzing or something, you sleep to that sound. It's quite familiar. But if there's a bang or a phone rings or something, we'll wake to something sort of unfamiliar that shouldn't be there at that point in time. And generally that stage lasts for about 15 minutes, if not a bit longer. So we're moving through these different stages of our sleep cycle, of the different stages within a cycle. The stages 3 and 4 generally go together. They're quite similar, and that's where our deep sleep occurs. And it's in that part of deep sleep that real physiological and psychological repair and restore takes place. And that's where the brain activity is showing delta waves. People differ in the amount of delta activity, but it's basically where we are properly asleep. And it's difficult to wake someone in that point. If you try and wake them up, they might wake up and they're disorientated, they don't know where they are. And that happens in that level of sleep. That's where our memory consolidation takes place. It's where growth takes place, and it can last up to 60 minutes in a cycle. And that's basically where things like sleepwalking can take place. Children can wet beds because our muscle tone is very relaxed. Okay, so those are the stages of the non-REM. But when that non-REM finishes, the final stage we move into is the stage of rapid eye movement. And suddenly in this stage, this is where there's a lot of brain activity that then happens, because we are they call it paradoxical asleep. So you can see at the top of the picture there, okay, the waves they're busy waves, okay, so the brain activity looks like we're awake, but externally our appearance is of deep sleep. And generally those periods of REM activity get longer in the second half of the night, and under your eyelids, your eyes are moving backwards and forwards, hence the name rapid eye movement sleep. At this point in our sleep cycle, our heart rate actually increases. Our blood pressure increases, our breathing becomes more erratic and irregular. In some people, this is where sexual arousal can take place. And it's at this point that people dream. So dream happens in this part of our sleep. So if awakened during this point of your sleep cycle, you will wake up, and if you've been dreaming, you'll probably remember vivid story-like dreams. Our major muscles become quite paralyzed. Okay, those muscles become quite rigid, and that's really a body's protective mechanism against acting out of our dreams. So if we're having a very vivid dream about fighting in a Roman battle or something, we don't leap out of bed and start swashbuckling a sword around the bedroom. We actually remain quite rigid, and that's our body's way of protecting us against that kind of thing. So the dreaming, that busy brain activity, happens in this part of sleep. So we go through a cycle where we basically cycle through stages 1 to 5, and then we don't go back to stage 1 because that's at first dozing off drowsy, but we move back into stage 2 again. And we go through those stages about 4 times in a night. So with the REM sleep, it sounds like it's a busy time of sleep. It's an active time for our brain. But it's that sleep that is important, because if we're deprived of that sleep, often that's where people get irritable and lack concentration. There's a larger portion of time in REM when we're sleeping normally. Infants spend longer times in REM. Up to 80% of their sleep cycle is spent in this REM phase. Adolescents and adults move to about 20% of their sleep cycle spent in this particular phase. And it's important because it helps the wiring in our brain develop, and there's correlations between our REM sleep and mood. People suffering from depression have longer REM sleep, and antidepressants can suppress REM sleep. So the sleep cycle is important, and getting a full sort of 4 cycles of sleep in a night is also important, which is why sleep is good. Sleep is healthy. It helps our body restore and repair, but at the same time, it's important we have sufficient of it and we move through our cycles in its complete cyclical stage. Okay, so do you understand sleep and the importance of sleep, and how our consciousness and our conscious awareness, so we're not unconscious during sleep, our levels of conscious awareness and what we're aware of changes. So like I said, the sleep goes through a stage 1, stage 2, stage 3. Some people have put the 2 stages together, stages 3 and 4, and then your REM sleep, and then you move back into the cycle again, and that happens 4 times in the night. So there's no specific brain area that says this is the sleep part of my brain. It's about brain areas and structures interacting that regulate sleep and waking, okay, including all of those that are in the picture, and this picture's from your textbook, just so you understand. So your cerebrum, your thalamus, your hypothalamus, your pons, your midbrain, your medulla, are all functioning when you're asleep, okay. The ascending reticular activating system, the ARIS, is a system that's involved in sleep, and that conveys neural stimulation to many areas of the cortex. Research has focused on the role of the hypothalamus, but basically the bottom line is that sleep depends on an interacting constellation of brain structures and those neural pathways that happen between the different structures in our brain. So that is what sleep is, why sleep is important, and sleep and our consciousness. So if we suffer from sleep deprivation, when we're deprived of sleep, okay, it's not a healthy situation. Sleep has a significant role in most systems in our body, and insufficient sleep increases the risk in all of these systems. So we know, and research has also told us, that the effects of sleep deprivation are impaired attention, impaired reaction time, impaired cognitive speed and accuracy, motor coordination, and even decision making. Okay, and some people, and there's a study in the textbook that's cited, and an interesting point from that study is that based upon people's ratings of their own sleepiness, many people do not appreciate the extent to which sleep restriction undermines mental functioning. So we might not be aware of it, but it does. It does impair our mental function, which obviously impacts how aware we are of things, which is our consciousness. Sleep loss can affect physiological processes in a way that undermines health. Okay. For example, sleep restrictions can trigger hormonal changes that increase hunger. Sleep loss can lead to health issues, including obesity, diabetes, hypertension, and even coronary or heart disease. Investigators have found that REM sleep appears to foster the recently discovered process of neurogenesis, which is where neurons can repair themselves. So REM has a function in that to help our brains start to function more optimally. Consistently less than 7 hours of sleep increases mortality risk. Okay, so it's really important to understand that sleep has an impact on our life expectancy. But as much as we can undersleep, if that's a word, we can also oversleep. So if we sleep for more than 10 hours a day, it can also have an impact on our mortality rate. So getting the right amount of sleep is really important from a physiological and cognitive function and psychological point of view. And what do we know about traffic accidents? Research tells us that drowsiness is a factor in about 20% of all traffic incidents, and it also contributes to incidents in the workplace and accidents in the workplace. So sleep is very important for our physical and psychological well-being. So to the point that there are sleep disorders. So one of the things we need to know is the different disorders that can happen during our sleep cycle. So people can suffer from nightmares and sleep terrors. A nightmare really happens when we're in that REM stage and we're dreaming and we recall a really vivid, ugly, horrible dream and we can't go back to sleep. Okay, that's what a nightmare is. Some people can suffer continually from nightmares, and it's that disruption in their REM sleep cycle. There's things called sleep terrors, where you might wake up in a panic, but you can't actually remember why. Okay, there can be a genetic predisposition for that. So a sleep disorder is someone who can suffer from nightmares or also suffer from sleep terrors. I think we're all aware of insomnia. Insomnia is about either not being able to stay asleep, maintaining sleep, or you actually can't fall asleep. So something like maintenance insomnia is where our sleep gets continually interrupted, or we always wake up very early in the morning. So there can be different factors with insomnia, whether you can't fall asleep, in which case you might be prescribed a sleeping tablet, or you might be prescribed something, or you might take something that calms you down before you go to sleep, like some kind of relaxant like Rescue or something, if you struggle to go to sleep, to try and overcome insomnia. And we'll see just now why insomnia is so important, why insomnia is actually an issue in mental disorders. And insomnia can be the result of stress or substance abuse or even a physiological disorder. But insomnia is quite common in people, especially now with the stress that many people are under. You might have heard of narcolepsy or cataplexy. Narcolepsy is a sleep disorder where during the day, when you are awake, your state of your REM state in your sleep cycle actually impinges into wakefulness, and it's called a sleep attack. That you might actually see somebody who's sitting at their desk working suddenly fall down fast asleep. Okay, so it's about that REM phase suddenly intrudes into wakefulness. And a cataplexy is a muscle paralysis. You know how we said in REM sleep, your muscle tension increases to protect you from those nightmares. A cataplexy is a sleep disorder that really replicates that, but during the day. It impinges in our wakefulness. So those are, again, types of sleep disorders where parts of our sleep cycle impinge into our waking cycle and can have an effect of either putting us to sleep straight away or otherwise paralyzing us the same way that our muscles become rigid during our REM sleep. You can have people who've got breathing related sleep disorders. So sleep apnea, that's where people actually stop breathing for a minute or two when they're sleeping. And they wake up gasping for air. So if you've got somebody or a partner who maybe snores and you have that really, and I won't even give an example of it, but that really sort of big gasp for air and they're snoring and then suddenly it goes silent for a minute or so, it's almost like they stop breathing in their sleep. And so what sleep apnea does is it's a disrupted sleep that you have. You're not sleeping properly, and it can be linked to heart disease, and basically because you never enter into the benefit of having that deep sleep. Can hallucinations be related to narcolepsy? No, I don't, Nikki, I don't know that. I would have to have a look and see. Narcolepsy is a sleep attack where you basically just fall asleep. Hallucination is a sort of distortion of various cognitive patterns in your brain to make you hallucinate about something. So I don't know if the two are related, but there might be a link. We would have to just have a look to answer that question. I can't tell you straight away, if that's okay. Can't answer that now, but I will look at it. Hallucinations related to narcolepsy. Sure. So, okay, somnambulism is sleepwalking. Okay, that's like we've got insomnia, now we have somnambulism, which is sleepwalking that generally occurs during the first 3 hours when we're in that slow wave sleep. So remember we looked at stage sort of 2, 3, and 4. It's where our body is now relaxed and we're going into our deep sleep, and that's where sleepwalking can happen. And when people sleepwalk, some people might be aware, but others are unaware, completely unaware that they're sleepwalking. Often it can be a genetic predisposition to sleepwalking, and often some sleeping tablets might have a side effect of sleepwalking. And obviously sleepwalking can lead to life-threatening accidents. If you've got somebody who just gets out of bed and walks out the house and down the street, it can obviously be life-threatening. So that is quite a serious sleep disorder that can happen. And another one you might experience is something called restless leg syndrome, and that's where at night you move your legs. Your legs are tingling, and they often move. And it's often, if you've got children who suffer from ADHD, it could be quite common in children whose brains are stimulated to move their muscles during the course of the night. So those are some of the sleep disorders that can be experienced that you need to be aware of. So when we talk about insomnia, and it's really just to show you the importance that insomnia might sound like a trivial problem, okay? But when we look at mental disorders generally, things like depression and anxiety, alcohol abuse and drug abuse, it shows that insomnia is very prevalent within those disorders. But also it's bidirectional in that if you've got somebody who doesn't sleep, who suffers from insomnia, there's more chance that they could become depressed. At the same time, if somebody suffers from depression, one of the side effects of depression is insomnia. So it can be very bidirectional. But what it says here is it's important to understand about insomnia as a sleep disorder, because it's a disorder in its own right, but at the same time, it's linked with other mental disorders, and the two things together can cause quite a disturbance in somebody's behavior. Okay, so if somebody suffers from anxiety, the chances is that they will suffer significantly from insomnia. But suffering from insomnia can also cause anxiety. If somebody abuses alcohol, they're very likely to suffer from insomnia. But if somebody suffers from insomnia, their day-to-day functioning is affected. There can be cognitive impairment. It can lead them into abusing alcohol. So that is just why it's important to understand how some of those sleep disorders work alongside other severe mental disorders. So I think that is the end of our content. But what I have done is I have just included 1 or 2 extra slides for you just to elaborate on some of the interesting levels of conscious awareness and altering our states of consciousness. Because remember that our states of consciousness can often be altered through things like drugs and meditation. So let's just look quickly at dreams. And really just because this is always interesting. And remember, Freud spoke a lot about dreams and about dream analysis and what dreams are. So one of the graph on the left-hand side gives you a nice indication of how, when we say our consciousness is being aware of things, but it's also to do with our levels of wakefulness. So if we look at awareness on one axis and wakefulness on another axis, when we are completely sort of unaware and we are unawake, we could be in a coma. So even though we're not, we've said that only when you die are you completely at a point in that bottom left-hand corner where you're not wakeful and you're not aware. If you're in a coma, there is a level of wakefulness there, and there is a level of awareness. Again, general anesthetic, there's a level of awareness and wakefulness. So it moves up a continuum to a point of being fully conscious as high levels of awareness and high levels of wakefulness, if you can see that picture. So it's sort of, if you put awareness and wakefulness on an axis like that, you can see the different states of consciousness within that. And as somebody in a vegetative state is somebody who's awake, but they're not aware. So if you say to somebody, they might have suffered a stroke and is awake, but they're not aware. So again, it's where you can see how those levels of awareness and consciousness work together. So what happens during dreams are conventionally defined as mental experiences. Our brains are working, our neural networks are firing, often with vivid imagery, and often they're story-like and often bizarre and seem real to the person actually dreaming. And often the contents of dreams spill over into our normal lives. So recent research shows that content is usually not bizarre and that dreamers are often aware that they've been dreaming. Okay. Content of dreams and culture. Many non-Western cultures, dreams are sources of information about oneself, the future, and the spiritual world. In African cultures, dreams can convey messages from the ancestors. So dreams have different themes, which can be linked to our culture. Which is also quite important. It's where in sort of African culture, that's where the ancestors come and speak to us and give messages. So dreams are important, often from a cultural point of view. Many dream theorists, so if we think back to Freud, Freud's dream analysis, the purpose of dreams is wish fulfillment, which the unconscious can attempt to censor and disguise. And Cartwright, another theorist, said our dreams enable us, that during our dreaming it helps us solve problems, that we're actually working through everyday problems in our dreams and our emotional issues, or working through those when we dream. So there's a lot of discussion about dreams and dreaming and what actually happens in that state of REM sleep. That is interesting, and again, it's something that you can look at and explore, and which will be explored in further modules in psychology, is the role of dreams. Another way to alter our consciousness is hypnosis. So hypnosis, you must have all heard of hypnosis. And basically during hypnosis, it's a procedure that produces a heightened state of suggestibility, but also relaxation, narrowed attention, and enhanced fantasy. So people use hypnosis as a clinical tool. So some dentists, for example, rather put people, or they don't rather, but there's an option of going under hypnosis. Psychologists use hypnosis in their treatment is people might use, you hear people about stopping smoking, they go through hypnosis. So it's a process by which it produces sort of a heightened sense of awareness or suggestibility. Okay, you've seen hypnosis on stage where people become very susceptible to suggestion, cluck like a chicken, and they cluck like a chicken. So we can reproduce phenomena that can be reproduced through hypnosis are many, including experiences such as anesthetics, hallucinations during his hypnosis, disinhibition. You do things you normally wouldn't do. People can make very suggestive suggest things to you, become very you are influenced by those suggestions, okay, and you might not even remember any of them. So what we're showing is that the states of consciousness can be altered through things like hypnosis. Trying to get this done before load shedding. Meditation, again, interesting. Meditation is a way of seeking higher consciousness. So it trains you to heighten your awareness. So we've said that awareness happens over the course of a day at different levels, but you can actually change your conscious awareness through focusing and heightening your awareness. You're doing it voluntarily. Okay, it's voluntary control over your level of consciousness. So it's about meditation, and meditation disciplines and being mindful. Okay, so when we meditate, again, it's healthy. It decreases our heart rate, our breathing rate, and our EEGs are relaxed. Okay, with mainly theta and alpha patterns. So it just shows you that meditation has an impact on our electrical circuits in our brain, and our brain becomes more relaxed. And it's a very beneficial state. So I'm just going to leave those slides there and you can read them. And obviously, the final thing is we alter our consciousness with drugs. And it's a very conscious effort to take drugs to alter our state of consciousness. Psychoactive drugs specifically modify mental, emotional, and behavioral functioning. So it affects our neurotransmitter functioning and it alters our consciousness. So some of the drugs that people take to intentionally alter their state of consciousness is things like marijuana, LSD, caffeine. We take caffeine to alter our state of consciousness, to make us more aware. We have a cup of coffee in the morning to wake us up and make us more conscious. Ritalin in children, treatment for ADHD, increases their ability to stay alert and conscious. So as much as our consciousness works through a sort of cycle in our circadian rhythm, and different times of the day we're more aware of things, it's something that we can actually alter through the use of drugs. So that is the end, I think, of consciousness. Oh, just drugs can impact health, obviously, and there's just some things there that impact our health with drugs. Guys, I hope I covered consciousness and that you've got a good understanding. Go back to the beginning and go back to that definition of consciousness. It's really important. It's the awareness of internal and external stimuli and how our levels of consciousness can fluctuate during the course of a day. But at the same time, we can also sort of adjust our own consciousness depending on various things. So my lights are about to go out because it's 7 o'clock. So I'm going to end this recording. If you've got any questions,